FOL stands for the first order logic is sufficiently expressive to represent a natural language statement. The syntax is nothing but the collection of symbols. The semantics is nothing but the statements what we have using those symbols. What is forward chaining? Forward chaining is also known as a forward deduction or the forward reasoning method when we are using with the inference engine. Hello everyone, welcome to the one more session on Artificial Intelligence and Application for 6th semester B.Ca student. Myself Induje, Faculty of Computer Science Department, Vidhyaashram First Aid College, the Temple of Excellence, MYSURU. In today's session, we'll continue the discussion on Unit 3, that is a knowledge representation. We have already discussed what is knowledge base, how we are going to represent the knowledge, what is knowledge base agent, what is logical representation, prepositional logic, and the drawbacks of the prepositional logics, right? So when we are saying it's a knowledge based agent, knowledge based agents works with the two things, that is one is a knowledge base and one is a inference engine or inference system. We have discussed what is knowledge base and what is inference system. We have two types in the inference system, forward chaining and backward chaining. That all thing we are going to discuss in this today's session. So let us start today's session. First order logic. We have how to represent the knowledge base. We can represent the knowledge base in two types, prepositional logic and first order logic. What is the main drawback we have in the prepositional logic is that prepositional logic works only with yes or no statement where we have a concrete answers. It cannot predict. To overcome from that type of situations, we have to use a first order logic or first order prediction logic, we can say. So let us have a definition for the first order prediction logic. We require some more powerful logic such as first order logic to overcome from the drawback of prepositional logic, right? So for example, what is that example? What prepositional logic cannot solve is some humans are intelligent. Either we cannot give the answer in true or false, may or may not be. We have to predict which human is intelligent, which is not intelligent. Such type of sentences cannot be represented using the prepositional logic. To represent these type of sentences, what we are using the first order logic. So to represent the above statement, prepositional logic is not sufficient. So we use the first order logic in such cases. What is first order logic? First order logic is another way of knowledge representation. What it is? It's a way of representing a knowledge for an agent. In artificial intelligence, it extends the properties of prepositional logic. We have adding some more additional features in the first order logic to the prepositional logic. FOL stands for the first order logic is sufficiently expressive to represent a natural language statement. We can represent the natural language statements using the first order logic. The first order logic is also known as predicate logic, or we can say it as a first order predicting logic or predicate logic. First order logic is powerful language that develops information about the objects in more easy way. It provides the information about the real world object in more easier way because we are representing the form of natural language and we can express the relationship between the objects in the particular environment. So when it comes to the first order logic, assumption of the following things in the word. What all the things we can assume in the first order logic? It will be having the objects as we are representing the environment, all the objects, and it will be having the relation between each of the object, and it will be having the function what that particular object has to do in that particular environment. Say object, what are all the objects? It can be a variable A and B, it can be a people, number, color, what, and thesis, square, pit, vampers, what we have discussed in the last session, vampers word problem. So these are all what? the objects what we have in the particular environment. So relationship, how we can provide the relationship? It can be a unary relationship, such as if it is a color, it is a red, if it is a shape, it is a round, is adjacent to, that object is adjacent to the other object, as we have seen in the Wampus word problem, the adjacent room, right? Adjacent room to the pit will be having the breeze smell, and the adjacent room to the Wampus will be having the stench. Like that, adjacent to or NRA relations, such as it may be a sister, brother, has a color, comes between. These are all the ways we can provide the relation with the objects. So this is not available in the prepositional logic, where it is available in the first order logic. Then functions, how we can provide the function for each object. That person may be the best friend, that person may be the father of him, or it's a third inning what he is playing right now, or it may be the end of the game. Like that, we are providing the functions for particular object, and it's to the relationship. The first order logic has two main parts. One is a syntax and semantic. Obviously, syntax and semantics is very important when we are representing anything in a logical representation. So let us see what is syntax and semantics of the first order logic. The syntax of first order logic determines which the collection of the symbols is a logical expression. What it is? The syntax is nothing but the collection of symbols. The semantics is nothing but the statements what we have using those symbols. The basic syntax element of the first order logic is symbols, right? So these are all the symbols what they have provided, and we write statements in the shorthand form of the notation as FOL. FOL stand for what? First order logic. What all the symbols? Constant, if it is a constant, it can be a constant's variable name or something like that. Then if it is a variables, X, Y, Z, as we are using in the C programming or any other programming, we can use the variables. Prediction, he may be the brother, he may be the father, he may be the sister, he may win the match today, like, so that is a predictions what we have. Function, that a square root, it's a left alignment, right alignment, implies. These are all the functions what we have. Connectivities what we have, and or not, implies, double implies. These are all the connections how we are providing from one statement to the other statement. Equality, we have a double equals to, and qualifier, it belongs to all, it belongs to one. In such case we use this. If it is belongs to all, we use this symbol. These are all some of the symbols what we have used in the first order prediction logic. Again, when we say that we have to represent in the logical representation, we have two types of sentences. One is atomic sentence and one is compound sentence. As we have discussed the atomic sentence in the prepositional logic, and we have a atomic sentence and the compound sentence in the first order logic. What is atomic sentence? Are the most basic sentences of the first order logic. These sentences are formed by a predicate symbol followed by the parenthesis within the sequence of terms. What we are using? We are using the predicate symbol to represent the sentence, atomic sentence. So here you can take the example how we are going to represent predicate. In this, what we are passing, the object which has to be passed as a parameter that we are passing. So it says these statements are formed from the predicate symbol followed by parenthesis with a squares in terms. For example, we can say Ravi and Ajay are the brother. This is a natural language representation. When we are representing in the atomic sentence of the first order logic, how we are going? What is the predictors? We have a brothers. What is this? Ajay and Ravi are brothers. So brother is a prediction. What all the objects what we are passing? Object is Ravi and then the Ajay. We have to pass that within the parenthesis as an argument. So here one more example, Chunky is a cat. What is the prediction here? Yes, cat is a prediction. What is the name of the cat? Chinky. Chinky is a name of the cat. We are passing only one object here. Okay, this is how we are going to represent the atomic sentence in the first order prediction. When it comes to the complex sentence, it is nothing but the combination of the basic atomic sentence forms a complex sentences. By using the connectivities, what we have, connectivities, not, nor, implies, and or connectivities we are using. The first order logic statements can be divided into two parts. These atomic statements or the compound statements will be divided into two parts. In the first part, what we have a subject, and the second part what we have is a predicate. What is the subject? Take an example. X is an integer. What is the subject here? X. We are referring to one particular object, that is called as a subject here. X is an subject and it is an integer. We are predicting that it is an integer. That is a prediction what we are doing. That is a predicate. A predicate can be defined as a relation which binds two atoms together. That is a prediction. So it says that it is an integer. What is a prediction? Is an. X is an subject and is an predictor, saying that it is an integer. That's what is explained in this statement also. Next, what is unification? Unification is nothing but forming the two sentences similar. That is called as unification. Unification is process of making different logics, that is atomic sentences, identical by finding the substitution. We are forming same sentences by using the substitution method. That is called as unification. Unification mainly depends on which process? Depends on process of substitution. It takes the two literal or the two sentences as an input and makes them into identical using the substitution. Here you can see the example. We have a psi 1 and psi 2. We are making this both the literals as similar, identical. That is the process of unification. How we are going to provide? By using the unify function. What all we have to pass is in a parameter. We have to pass both the psi 1 and psi 2, which are the parameter that has to be passed to the function unify. So unification, unify algorithm is used to unification, which takes the two atomic sentences and returns the unifiers of those two atomic and make it as identical. Unification is a key component of first order inference logic. Why we have to go for unification? Because we have to use a first order logic, right? To first order logic, we have to go for unification. It returns a fail if the expression does not match with each other. If we are not able to substitute and make it identical, then it will return the value as fail, right? The substitution variable are called most general unifier. The variable or the literal what we are substituting, that literal is called as most general unifiers. Let us see the algorithm for the unification. Unification algorithm, we have a psi 1 and psi 2 as a two literals. Using these two literal, what are the steps we have to follow to form the unifications? In the step 1, what is it is saying? It is a condition where unification can be failed, right? So variables are the constant. It can be a variable or it can be a constant. If S1 or S2 are the identical, then return nil. Because it is already identical, we no need to do anything. So we are returning a nil there. So yes, what we have to check? We have to check psi of 1 is a variable. If psi of 1 is a variable, then what have to do? Then psi of 1 occurs in psi of 2, then it returns fail. Why it is fail? Because two same literals cannot occur more than one time. That's why it returns as a fail. That is a condition what we have for the unification. Then what it has to check? Then return, we are dividing psi of 2 divided by psi of 1 to reduce this failure condition. Then else we are checking, firstly we are checking psi of 1 is a variable. If it is true, then we are executing this statement. Then what we are checking, if psi of 2 is a variable, we cannot again go for the substitution, because again the same condition happens, where if you substitute psi of 2 with psi of 1, again there will be the same literals or more than one time, so that fails the condition of unification. So we cannot say that, so it is also a written. So then in the second step, what we are doing, if the initial predicate symbol psi of 1 and psi of 2 are not same, then directly we can say that the unification is not possible. In the first step, what we are checking, whether the psi of 1 is a variable or psi of 2 is a variable. So we cannot go for the substitution if it is a variable. So that is one condition for unification to be failed. And the second condition, initially only they are checking whether both are possible to substitute or not. If it is not possible, then directly we can say unification is failed. In the step 3, what we are doing, if psi of 1 and psi of 2 have a different number of argument, then return fail. If you want to go for the substitution, say L1 and L2 are the two literals what we have. L1 has a 3 parameters or 3 arguments, A1 and A2 and A3. So 3 arguments. L2 has 2 arguments, A1 comma A2. At this condition also unification is not possible, because number of parameters what we are passing for the two literals should be same. That is one more condition where unification can be failed. So in the fourth step, set substitution as nil. Substitute, take a variable for the substitution and put that variable value as a null or nil, and execute this substitution within the for loop. This all statements. Step 5, we have substituting the variable, substituting so that we can get the unification or the identical statement expressions. Okay, call the unification function with the ith element of psi of 1 and ith element of psi of 2 and put the result into S. Where we are putting? We are putting the result into F. If S is failed, then return failure. If S is not failed, then put it as not nil, then do following. What you have to do? Apply yes to the remainder and both L1 and L2. Then we have to go what? Substitute the value of L1 in the place of L1, where literal with the literal 2, or you can substitute the L2 in the L1 literals. So this is a substitution method. After doing the substitution, what we have to do? We have to return the element. What is the element? Substitute element. We have to return the substitute element to check it forms the identical sentence or not. That is all about the unification. Next, what we have is one more very important knowledge representation is inference system. How we are using the inference system? There are two types. So we can use the inference system by using forward chaining and backward chaining. Let us discuss what is forward chaining and what is backward chaining, and with an example for each. So what is forward chaining? In artificial intelligence, forward and the backward chaining is one of the most important topics. Before understanding the forward and backward chaining, let us understand where these two sentences we have already used. We have already used these two sentences when we are dealing with the inference engine in the session 1 of unit 3. Like, the inference engine is a component of the intelligent system in the artificial intelligence, which applies the logical rules to the knowledge base to infer the new information from the known fact. What inference engine will do? Inference engine will observe the environment. Okay, it compare with the knowledge base and forms the new sentences. How this can be done? This inference can be a part of the expert system, and we can do this by using two things, two techniques, that is forward chaining and backward chaining. Let us see what is forward chaining and backward chaining. Before going for forward chaining and backward chaining, one more important concept you must understand. What is that? That is clause. Horn clause and define clause. What clause means? We have to know one more concept, that is a clause. What horn clause and what is definite clause? What clause means? Clause is an expression. Clause is an expression used to form a sentence or the statement. Okay, horn clause, when it comes to a horn and define clause, are the forms of sentences. It's a form of sentences which enables the knowledge base to use more restricted and efficient inference algorithm. We can use this clause. Why we have to use this clause? To make the efficient use of inference algorithm. A logical inference algorithm uses forward and backward chaining approaches which requires the knowledge base in the form of first order defined clause. In the first order defined clause, we are going to use this horn clause and then the defined clause. What is this horn clause? Horn clause is which disjunct of literals which with a most one positive literals known as a horn clause. What is literal? This is P, Q and K are the literal. We are expressing we are providing the statement in the form of expressions, right? So when we say it's an expression, we definitely have the literal. Literals are the variables, right? So we are representing these literal where at most one positive literal should be there. Here you can see it is a negation of P, negation of Q and one positive literal is there. So if such condition is there, we call it as a horn clause. What is a clause here? It should have at most one positive literal. It may have any number of negative literals, that is irrespective. When it comes to the definite clause, in the definite clause you should have exactly one positive literal known as a definite clause or strict horn clause, where it is not allowed with the negative literals. It should have only the positive literal, that is a definite clause. In the horn clause, we can have one positive literals and any number of negative literals will be there in the expression to represent the sentence. This is all about horn clause and the define clause. What is forward chaining? Forward chaining is also known as a forward deduction or the forward reasoning method when we are using with the inference engine. Forward chaining is a form of reasoning which start with the atomic sentence, very simple sentence in the knowledge base and applies the inference rule. That is, what is the inference rule? That is a modulus Prohn rule in the forward direction to extract more data until we reach to the goal. What we are doing? We are applying these rules. We are applying these rules to reach to the goal with the atomic sentences. The forward chaining algorithm starts from known facts. What is known fact? Known fact is nothing but your knowledge base. What knowledge is already given to the system. Known fact triggers all the rules whose permissions are satisfied. It will take all the rules, it will study all the rules, understand and make the implementation and add their conclusion to the known fact. Whatever the conclusion that comes from the statements, it will be added to the knowledge base again to increase the knowledge base. This process repeats until the problem is solved. How long this process will repeat? This process will repeat until we reach to the goal. So what is the properties of forward chaining? Properties of forward chaining is first and foremost, it's a down up approach. Down means it moves from down to top. Down up approach, it moves from bottom to the top. It is a process of making the conclusion based on the known fact. We don't know what is the conclusion, what may be the output. Just we are following the known fact and finally we are reaching to one conclusion. With these knowledge, whatever we have, we are getting this conclusion. We are getting the conclusion out, what the conclusion may be. So that is the process. We are following from bottom to the top. We don't know what should be the output, right? But with the known fact, we are trying to reach the output by starting from the initial state and reaching to the goal state. The forward chaining approach is also called as a data driven. Why data driven? Because we are working on what? We are working on known fact. We are working on known fact. Which is a known fact? Known fact is nothing but my data. That is what we have given. We can known fact, data driven, we reach to the goal by using the available data. Forward chaining approach is commonly used in the expert system. Where we are using that forward chaining in the expert system such as CLIPS and the business modules and the production rule system. These are all the areas where we are implementing the forward chain technique. So let us see the example for the forward chain technique. So here what we have, these are a set of rules that is provided, that is a knowledge what we are providing, that is what is known as known fact. Known fact. Yes, this is a known fact, that is what we have given. It means A and C implies F and A and E implies what? G and B implies E and G implies D. And what is the database we have? Database is AB. This is a known fact what we have. We have AB, only AB in the database. Okay. Using this known fact with help of the data what we have provided, we have to form the new database. We have to update that data. So that how we can do that by using the forward chaining. So what is the problem here? We have prove if A and B are true, then D is also true. Where we have a D? We have a D here, right? If A and B are true, then D is also true. We don't have a direct implication from A to B, from A or from B to direct D. So what we have to follow? We have to follow some forward chaining algorithm steps to prove that if A and B are true, then D is also true. What exactly we are going to check? Check for A and B combination in the knowledge base. In the known fact, do we have A and B implies something? No, right? So we cannot use any of these rules initially. Then what we have to check? Check for the A combination in the knowledge base. Does anywhere A is implying or A is giving the result D? No, right? Then what we have to check? We have to check for the B combination in the knowledge base. Yes, we have B combination. B implies E, right? So we have to execute this. We have to execute this. B implies E. We are executing B implies E. In that case, what you meant by executing? Moving that particular variable or the literal to the database. Initially, what we had in the database, A and B. Now we have executed E. E will go to the database with the help of what? With the help of rule number 4, that is B implies E. Then after executing E, now database is having how many literals? A, B and E. After that, repeat the same step. What the step we have to repeat? We have to check. A is there, B is there and C is there in the database. A and C, that is A and E implies what? G, right? So we have that as in a rule number 2. That is matching with the knowledge base what is provided. This which knowledge base? This knowledge base. A and E implies G. Knowledge base what is provided. So put a G in the database. So we have to execute what? We have to execute G again. Now this knowledge base will be updated as A, B, E and G, right? With the 4 literals. Execute G in the database. After executing G, we have how many elements? A, B, E and G elements in the database. Now repeat the same step. Check for the new variable D implies D. What is our goal? Our goal is to reach to the D. So, G implies D is matching with the knowledge base. That is our rule number 4 in the knowledge base. So, execute this D into the database. Now, we are adding A, B, E, G and D into the database. Having all the 5 literals, that says if it is there in the database, A and B is true, then D is also true. Hence, we can prove that both the, if A and B is there database, we can add E, G and D to the database. When we reach to the goal state, we can stop. This is what the forward chaining will do. Then coming to the backward chaining, one more method. What is a one more method we have? That is a backward chaining. Backward chaining is also known as a backward deduction or the backward reasoning method. As the name itself indicates, we are moving from top to bottom. As in the forward chaining, we are moving from bottom to the top. We don't know the destination, so we are making use of the knowledge. Here we know the destination, we know the result, what should be the output. From that result, for that result, what all the knowledge base I can use. That is the concept of backward chaining or backward reasoning. A backward chaining algorithm forms the reasoning which starts with the goal. It starts with where? Goal, and works backward chaining through the rules to find the known facts. So that is what is the properties of backward chaining. As just I mentioned, it is a top-down approach, where the forward chaining is a bottom-up approach. The backward chaining is based on the modus prone inference rule. Obviously, we are working for the inference rule. Both the forward and backward chaining will depends on the same. In the backward chaining, the goal is broken into the sub-goals, or the sub-goals to prove the fact is true. Whatever the fact we have taken, we are proving those facts are true because we already know the goal state. It is called as goal driven approach, where forward chaining is what? Data driven, but the backward chaining is a goal driven approach. Why? Because we know the goal. From the goal we are reaching to the facts. That's why we are called it is a goal driven approach. Backward chaining algorithm used in the game theory. Where all we are using the backward chain? In the game theory, automated theorem proving tools, inference engine, proof assistance, and the various AI applications, we are using the backward chain technology or techniques. The backward chaining method mostly use the depth first search strategy. Which strategy it will use? It will use a DFS, depth first search strategy it will use. So let us take the example. We have a knowledge base, all the facts, known facts. We have a 3 rules here. And what is a database we have provided? Facts is provided A, E, B, C. So what is the database we have? That is fact A, E, B and C. That is what we have. Here what we have? F and B implies Z, C and D implies F and A implies D. So what is the problem? Goal is to get Z, which is not there in the given fact. We have to get Z. How we are going to get Z? Where Z is there? Z is there in F and B. F and B, we don't have F and B in the fact. So what I have to do? I have to move this. For moving this, what I need? I need either F or B. Where I do get F, I do get the F in the rule number 2. From the rule number 2, what I get? C and D, right? Once I reach C and D, once I get F, I can get Z easily. So that is what the backward chaining. What exactly we are doing? Want Z. So check in the facts. In the fact, Z is not present. So present there. So check in the rules. Where Z is present, F and B, then Z. Rule 1, driving what? Driving Z by F and B. Now get F and B. B is already there. What we have in the database? The data fact A, E, B and C. What we have in fact A, E, B and C. Have to get the Z here. So what we have checked for the Z. So Z can be available with the F and B. B is already there, right? So I have to check for F. B is already matching. So get only F. What have to get? F. So getting F. Where I can find F? I can find F by C and D. C and D implies F, right? So we have to get F here. Sign. After this rule, what we have? We have C and D. We have already C. We no need to get C because it is already there in the fact. Now what I have to get? I have to get D. That is what we are doing. Now get D to the facts. Now to get D, what exactly have we have to use a rule number 3. That is A implies D. That is rule number 3. Once we get this D into the database, what we have to do? Now get A is already there matching, because A is already there, we need not to get anything from that. After getting this, we have to execute by using the forward chaining. What forward chaining will do? So what after this backward chaining, what we have in the facts? A, E, B, C with F and D. These are all the facts what we have. By using this fact, can I reach to the D? Can I get Z? Yes, definitely I can get Z, because F, C and D gives F, and here F and B will give Z, right? So both F and B is there in the database or in the facts. So hence F and B both are there in the fact. I can get Z also, right? A, E, B, C, F and D we have. Using this F and B, I can get this Z. So this is what is backward chaining. Apply reverse. Once we got the fact, we have to again use the forward chaining to go to the goal. This is all about forward chaining and the backward chaining with their properties and the example for both. This completes your unit 3. Thank you.